Well, good evening and good morning for the folks on the East Coast. My name is Dwayne Brown with NASA's Office of Communications. You are here where NASA's Mars MAVEN spacecraft has successfully been placed in orbit. We're here at the Lockheed Martin facility in Littleton, Colorado, where you will hear how it was done and the next steps. This is truly a happy ending to a new beginning. We'll have brief remarks from our participants, and then we'll open it up for questions. And these folks have a lot to do, so we're going to try to keep this short to about 30 minutes. So we'll ask you to limit your questions to one. You can bring your questions or ask your questions on hashtag AskNASA. And we'll start with questions here, and then we'll wrap it up. So before we hear the remarks, let me introduce you to the folks here. First up, John Grunsfeld, astronaut, associate administrator for the NASA Science Mission Directorate, NASA headquarters in Washington. David Mitchell, MAVEN project manager, NASA's Goddard Space Flight Center, Greenbelt, Maryland. Guy Butershees, Lockheed Martin MAVEN program manager, Lockheed Martin Space Systems Company, Littleton, Colorado. And a very, very happy gentleman at the end, Bruce Jakosky, the MAVEN principal investigator from the Laboratory for Atmospheric and Space Physics, University of Colorado in Boulder. And with that, John, your thoughts?
Well, I'm just really excited to be able to talk to you this evening with a very happy group of people having put the MAVEN spacecraft into Mars orbit. Stepping back just a little bit, though, and thinking about what an amazing accomplishment this is. We often talk about how Mars is hard. And once again, this team made it look easy, but it certainly wasn't. It represents years of work, very complex work. And it's just incredible to me that we're able to accomplish these things, and that MAVEN has joined a fleet of spacecraft, including the Mars Reconnaissance Orbiter, Odyssey, Curiosity, and Opportunity at Mars, and reflects this incredible quest to unravel the mysteries of the universe and to try and understand Mars. This really is a quest of humanity. It's an international quest, and it was a team effort to get MAVEN into Mars orbit. It represents the start of the MAVEN mission and the science mission, which is why all this effort was made, and Bruce will talk more about that. I just want to thank all the team members, and in particular the family members that had to suffer while all these folks were working weekends and nights. And I also want to thank the family members for all the weekends and nights that the science team is going to be working while the MAVEN mission is doing its incredible work. So with that,
David?
Hand it over to David.
Wow, what a night. You get one shot with Mars orbit insertion, and MAVEN nailed it tonight. So we've got a really happy crew in the building here and across the country and literally around the world. So just really excited for the crew and their families, as John just mentioned. So thanks to everybody for the hard work to get to this point, many years, and so we look forward to the years ahead. And so I'm simply going to talk a couple minutes about where we are in the orbit, and then Guy will talk about spacecraft health, but really things look really great with the orbit at this point. Navigation solutions were very stable before MOI and showed a nominal approach direction with arrival altitude at a good safe distance. MOI was successfully executed. The duration of the burn, and these are all preliminary numbers, but as it stands right now, the duration is 34 minutes, 26-second burn. That was about 11 seconds longer than the nominal, which really means we nailed it. I mean, MAVEN nailed it. It was right on the money, so really happy about that. All the observed navigation data is within nominal range. Post-MOI orbit assessment, and it's active right now. It's going on as we speak, and we'll be meeting later about that tonight. But tracking data indicates we're in a stable capture orbit. The orbit period is near the target of 35 hours, so this is the first initial orbit. And then our first pass back into periaps, or lowest portion of the orbit, that'll come the next time around past Mars is calculated to be near 380 kilometers above the surface. And that really is right on the money on that one. That was what we had planned for. So in the next couple of days, we'll do our second burn. We have a total of 5 burns coming up to walk it down from the 35-hour orbit to the 4.5-hour orbit that we'll have our science in. So we'll do what's called our periaps lowering maneuver number 1 in 2 days, and look forward to that. And but again, so far so good. Really happy team out here, and I'll turn it over to Guy.
All right, so I'm going to just kind of walk you back through what we did on the spacecraft side. We started right before the maneuver doing what we call a pressurization event. We have a tank of helium, high pressure helium on board that's isolated behind these valves that are pyrotechnically activated. So it's isolated all the way through cruise, and we fire those valves to allow the helium to flow through a regulator to our propellant tank. And the reason for that is that maintains a high pressure during the burn to allow the burn to be efficient. So that went well. That was one of the stressful points for the engineers, because that's one thing. These are pyrotechnic valves, which means you can only fire them once. So you can't really test them, because if you fire them, you got to take them out and put in a new one. So that was one of the events we were watching very closely, but it worked flawlessly. At that point, we slewed the spacecraft. It had been flying with its high gain antenna pointed towards the Earth, but we needed to slew so that the main engines would be pointed in the proper direction. That takes our high gain antenna off of the Earth. So we switched to low gain antennas that have a much wider field of view. The down point is that we had to drop to 40 bits per second. So we had a little lower telemetry rate, so it made it a little more nervous watching the burn. But the slew went well. We started right on time, as Dave said. We have accelerometers on board, and we use those accelerometers to basically measure the change in velocity as the engines are burning. That allows us to get a very precise injection cutoff. And they cut off at the planned 1,230.5 meters per second, which corresponds to about 2,753 miles per hour. We used up, this is a preliminary estimate, but approximately about 260 gallons of rocket fuel. We then slewed back to Earth Point to get the high gain antenna back, pointed at the Earth, and that allowed us to bump up the downlink rate to 285 kilobits per second, and that's where the team is right now. So we're getting the data down, and we're analyzing all that data. The preliminary look is that all systems seem to be healthy. We don't see anything that is that shows a problem. But again, we're downlinking all this high rate data and the data we recorded during the burn so that we can do some more in-depth analysis and make sure that that everything is as expected. I would like to say that, kind of echoing what John and Dave said, you don't realize, people won't realize how much hard work went into this, how much behind the scenes stuff went on during the design phase, how much testing the team did, how many contingencies that we went through, what if scenarios, what if this happened, what if that went wrong. It really is an amazing amount of work that the team did to make it look so smooth tonight. It's kind of cliche. People walk around going, it's not rocket science. Well, sometimes it is rocket science. I'm very proud to be part of this team, and I just want to thank them for all the hard work they've done. So now I'm going to turn it over to Bruce to tell us about the great science we're doing.
Thank you. I think my heart's about ready to start again. We've been developing this mission for 11 years now, from the original concept that we wanted to propose. And I can't tell you how many requirements reviews, PowerPoint proposals, how much paper we pushed to get there, how many reviews along the way, how much effort the team put into the design, the development, building, testing the spacecraft, launching it. Then we had a 10-month cruise and an absolutely flawless performance tonight. It just amazes me that we're able to do this, and as they've said, to do it and appear for it to be so effortless. It's a real testament to the team. I think I want to send my thanks and my congratulations to the team. We've had over 600 people working on MAVEN at different times throughout its lifetime, and we've gotten here because of the incredible commitment and dedication of each one. I've come to realize that every single person wearing one of these MAVEN shirts tonight thinks that they are doing absolutely the coolest thing they can be doing, and they have put their heart and soul into each job that they're doing to get us here. And I think that's why we've been successful at getting here and making it look so effort, because of the tremendous effort they've put into it. I want to echo Guy's and Dave's and John's thanks to our families. They put up with an awful lot. You don't realize until you go through this what it takes to do this, and what the families especially have to put up with in terms of lost weekends, travel, the tremendous effort that it takes. I also want to take a step back. We've had a tremendously successful night tonight. We are anxiously awaiting the arrival in 2 days of the India MOM mission, and we're hoping for their success. We're sending them the best wishes from the entire MAVEN team for a successful orbit insertion and mission. All I can say at this point is we're in orbit at Mars, guys. And we've taken 11 years to get here, and now we get to do the science that we've been planning for all this time. So, Dwayne, I'll throw it back to you. Thank you.
Well, folks, before we open up for questions, let's give this incredible team a round of applause. Congratulations.
Thank you.
Okay, just a reminder that you can send your questions in to #AskNASA. And again, these folks, their work is just beginning. We're going to keep this short to about 30 minutes. So if you can keep your questions to one. If we have some time, maybe a follow-up, and then we'll see if any of the social media folks have a question if we're running good on time. So if you can raise your hand here. Again, #AskNASA if you're looking at this from around the country, and name and affiliation, please.
Is there a mic or not?
Yes. Do we have a mic?
On the way.
We do have a mic. And so while we're waiting for a mic, one more plug for the #AskNASA for the folks who are watching this. Name and affiliation. Good.
Thanks. This is Alex Witzy from Nature. For Bruce, can you talk about what's going to unfold with the science instruments, which ones get switched on in which order, and when we start to get data back from the various instruments?
Let me start from when we start the science mission. Over the next 6 weeks, we have to do commissioning of the spacecraft. That requires us to do maneuvers, as Dave said, to get into our final mapping orbit. We have to deploy the booms. We have 4 booms to deploy with instruments at the end. One of the instruments, the NGIMS instrument, has a cap that has to be deployed off of it, called a break-off cap. We have to turn on the instruments, test them, do some calibration of the pointing, do an end-to-end relay test using our electric communications relay to send data to and from the Curiosity rover. All of this is going to take about 6 weeks before we're actually ready to do science. So we're looking at early November as the official start of science. On the way, we have what I'll call a bonus opportunity with Comet Sighting Spring. That is a comet discovered last year that has a close approach to Mars on October 19th. It's going to miss by only 132,000 kilometers, which is almost nothing. We're going to take 5 days out of our commissioning in order to make observations of the comet itself and of the Mars upper atmosphere and solar wind environment, both before the comet approach and immediately following, so we can get a before and after look at the upper atmosphere. So that's 5 days centered on October 19th. If we have the opportunity, we'll be turning instruments on sooner and getting some additional early science, but that depends on how the next hours and days unfold.
So we're going to Leonard, and then we're going to go to the Ask NASA questions.
Yeah, Leonard David with space.com. I think it was Dave that talked about the walk-down maneuvers, and can you just describe maybe the first one, and are they all different the
Yeah,
5?
there's different durations, and so the I'm trying to think of the exact times, but basically the second one of those, the period reduction maneuver, that's got the longest burn. It's actually, I don't have the numbers right in front of me, but it's not as significant as the MOI burn we just went through, but I want to say about a third of that amount of a burn. So it's that's a big one, and they're all designed to, you know, we wanted to carefully get into a larger orbit before we dialed it in, so to speak, and so again, the first one happens in a couple of days, and the last one will happen, I want to say, about 10 days out, on that order. In early October, we'll do the last one, and then we'll be on our final 4.5-hour orbit, and that'll get us as low as 150 kilometers from the surface in its periapsis. Yep.
Okay, let's go to my colleague Jason Townsend, who is monitoring the questions coming in from #AskNASA. And Jason, what do we have on the internet there?
Hi, so we've got our first question coming in from Twitter user Freelance Philos asking, where can the community get data from MAVEN?
Let me take that one. Once we start to collect data, we'll be releasing some of the early results as quickly as possible, and the data will be available on our various websites. We've got one at lasp.colorado.edu/MAVEN, and of course nasa.gov/MAVEN. We're anticipating that we'll really begin to understand the data and start to get preliminary conclusions for the goals of the mission after about 3 months. So we're looking at early in the calendar year to really be getting our results out.
Another question, Jason?
Twitter user Jonathan asks, is there anything specific that you're looking for and or expecting to find in Mars' atmosphere?
What we're trying to do is to respond with this mission to observations that tell us that the climate has changed on Mars significantly over the past few billion years. We're trying to understand what the cause of that climate change has been, and we're looking at the role that escape to space may have played in removing the atmosphere and changing the atmosphere. So we're looking at what happens at the top of the atmosphere, how the processes involving the sun and the solar wind affect the gas at the top of the atmosphere and strip it away to space. So in essence, that's our goal, to answer the question, where did the water go? Where did the carbon dioxide go?
Okay, do we have any more questions here? And then we have here, and here in the front.
Laura Keeney with the Denver
Wait, you can wait for the mic?
Of
Good.
course.
Good. Name and affiliation.
Hello, I'm Laura Keeney with the Denver Post. Tim Preiser came down earlier and he was talking to us about the fuel. And I understand that you were expecting to use 25 gallons to get out there, but it only used 5. And I put that on Twitter, and a lot of people have been asking why, and what impact is that going to have on the mission?
Yeah, I'll take that. Yeah. We budget, our fuel during the design phase to make sure that we can accommodate all kinds of scenarios. So there's uncertainties in performance, for instance, on the launch vehicle. But the launch vehicle gave us a fantastic ride and put us right where we needed to be. So we had budgeted extra fuel in case the launch vehicle left us off slightly off of the target. So that went well, so we didn't have to use quite as much fuel there. We had planned for what we call trajectory correction maneuvers, or TCMs. These are maneuvers where we change the trajectory. We'd planned for 4 of them, but the first 2 went so well due to a combination of the great navigation work out at the Jet Propulsion Laboratory and how well the spacecraft behaved. So when we did those maneuvers, the spacecraft executed those burns exactly right where the navigators wanted us to do them. So we had uncertainties budgeted for thruster performance, uncertainties in terms of our attitude control. All of that really came right down the middle. And then the third piece of that was we worked very closely with the navigation team to help them model any kind of delta V that comes from the spacecraft so that they can put that into their navigation solutions. The better you model it, the better they can design those first 2 maneuvers and then because it was so well modeled and the spacecraft was so well behaved, we actually got to cancel the third one and the fourth one, which is, you know, a testament to all the hard work of both the engineering team on the spacecraft and the navigation team. So it really was when you budget for problems and then the problems don't occur and your design behaves exactly as you designed it, good things happen, like a lot lower fuel use than you'd planned.
Does that mean the mission can go longer then?
The more fuel we have, the more we can give it to Bruce for getting more science and extending the mission, so yes.
Okay, we're going to take one more question here, a couple more from Ask NASA, and then we're going to wrap up. Go ahead, sir.
AJ Smith with Audible Designs. I was wondering, what did we learn on the LADI mission that makes this different or better than the MAVEN?
Well, the LADI mission was a mission to the moon, and we're at Mars, so I'm not quite sure I understand your question.
Well, they were both to sample the atmosphere to see what was in them before it was polluted.
So, well, the moon, you know, most people think it doesn't have an atmosphere, but in fact it has a very thin and tenuous atmosphere, and it's a combination of volatiles and other elemental abundance that's coming from the moon in an exosphere. And in particular, studying the fact that the moon is almost a complete vacuum, you know, the questions about electrostatic elevation of dust and things like that. But it is very different from Mars. Mars has, you know, a relatively thick atmosphere compared to the moon, a very thick atmosphere compared to the moon. The more interesting comparison is that we have, you know, a fleet of Earth science and weather satellites around the Earth for us to understand the Earth's atmosphere. And the Mars atmosphere being something like the Earth's, MAVEN is more akin to our Earth observing satellites. But somehow Mars changed billions of years ago from a thick atmosphere like Earth to the very thin one today. And that's the big mystery that Bruce and his team with MAVEN are trying to solve.
Jason?
Wonderful. This next question comes from Twitter user Ideash, who asks, is the riskiest part of the MAVEN mission behind us?
You want me to, I can give it a
Sure.
shot. Okay, so there's gates along the way. So launch is a big deal. Mars orbit insertion is certainly a big deal. And we have a series of deployments that Bruce already described that are coming up in October. So every one of these steps, we breathe another sigh of relief. And it is because, as Guy said, because of the testing and all the work that's been done. But nonetheless, they're big events that have to work. And so we, you know, I don't want to say what risk is the highest, but everyone has to work along the way. I personally will breathe a lot easier November 8th when the science starts. That means all the deployments have worked, all the checkouts have been finalized. So, but space is hard. You know, the space flight is hard, and but it's great to knock off one of the big risks tonight that we had with Mars orbit insertion.
I'll breathe a sigh of relief after the one Earth year mission. The primary science is done, then I'll breathe a sigh of relief.
And I'm looking forward to that extended mission when we've gotten a whole solar cycle.
Jason, let's take one last one before we wrap up.
Sure. This question comes from Twitter user OKNowRun, who asks, are there any superstitions observed by the MAVEN team before or after MAVEN's Mars orbital insertion?
Sure. Yeah, I'll throw one out. It's a common tradition to bring peanuts to both launch events and orbit insertion events. Peanuts are considered good luck. And then we also, our fall protection engineer brought in Mars bars. So I think that's going to become a new tradition as well.
Okay, that's going to do it. I want to thank you all for letting us stay within the time limit. We're actually going to end a little earlier. These folks, their work is just beginning. And if you're just joining us here, the Lockheed Martin facility in Littleton, Colorado, the Mars Atmosphere and Volatile Evolution of MAVEN spacecraft has successfully entered Martian orbit. The work is beginning. You can get updates on www.nasa.gov/MAVEN. Join the conversation. A lot of talk on Facebook, Twitter. Keep those questions coming in at #AskNASA. And we'll have scientists available to answer those questions, so just keep them coming in. And again, congratulations to the MAVEN team. The journey to Mars continues.